Hello makers, I'm Boldy and today I have a serious question for you. Have you ever wanted your toilet to be smart? No? Well, neither did I, but here we are. Me making a video about it and you watching it. So buckle up and get ready for a journey through the fascinating world of IoT toilet controllers that will make your bathroom experience not only pleasant, but also eco-friendly. And we all know Mother Earth needs a break. So how did I come up with this brilliant idea? Well, my Airwick air freshener would constantly spray even when no one had used the toilet, wasting precious resources. Additionally, the ventilation fan was attached to the light switch, turning on every single time the lights went on. This clearly called for some optimization, and as a bonus we'll throw in some temperature measurements for good measure. I started this project by designing the circuit with EasyEDA and creating the case using Tinkercad, both fantastic user-friendly apps that are free and perfect for a simple DIY project like this. The electronics consist of 3 wire-connected modules. 1. A panel with buttons and indicator LEDs. 2. The main module housing the microcontroller. And 3. The power module which takes 220 volts AC and transforms it to pure 5 volts DC. For safety reasons, I designed the case to separate the high voltage module. First, my son and I soldered and assembled the panel with buttons and indicator LEDs because family bonding over DIY projects is just priceless. Next, we tackled the main module with the microcontroller. This project is a great opportunity to learn how to use a multimeter's continuity function to determine the default state of a relay and to perfect your soldering expertise. To make custom connectors, we used standard headers and ribbon cables, securing them with hot glue afterward. I'll demonstrate how to make sure that the custom created header connector can be plugged in only one direction, avoiding potential mishaps. After soldering all main components to a proto board and connecting them according to the schematics, our 3D printer finished printing the necessary parts, like magic. We did some testing before putting it all together. And started by assembling the high voltage module, followed by the microcontroller, and finally securing the switches and controls to the case. Now to control the Airwick air freshener, I came up with an ingenious method involving a piece of paper between 2 washers and a battery holder, allowing me to connect and disconnect the battery using a relay and my trusty microcontroller. With the finished product in hand, I realized the ESP8266 had a weak Wi-Fi signal, so I added an antenna, a delightful last-minute touch. To detect when someone flushes the toilet, I hot glued a limit switch to the toilet's water tank. Finally, I configured the EasySP firmware and set up Node-RED rules for efficient and precise toilet control. If you'd like to explore more about this project, check out the related links in the video description below. And there you have it, folks, the IoT toilet controller of your wildest dreams. A project to optimize bathroom efficiency, bring some fun to the mundane, and offer you precious temperature measurements as a bonus. Who knew your toilet could be so smart? I hope you had as much fun watching this tutorial as I had making it. If you enjoyed this quirky and useful DIY adventure, don't forget to hit that like button, share your thoughts in the comments, and subscribe for more entertaining and innovative projects. Happy DIYing, and may your toilets forever be fresh and well ventilated.